Test 1 concludes our examination of the categorical syllogism. We're finished with that information. You should turn your attention to Chapter 8, Symbolic Logic. We're still going to be dealing with deductive arguments, and we're always concerned with their forms being valid or invalid. These arguments are real different from the kind we just concluded. For one thing, they can have any number of premises, not just two. Their premises or their conclusion could be either a simple proposition or a compound proposition. And their validity is not a matter of how class members are related to each other. It's a product of the truth values of the component simple statements. Whatever else all that means, it means that we need to learn a new symbolic language so that we can translate English arguments into it and then subject them to a couple proofs of validity or invalidity. Our language has two versions. One version is used to begin with and produce arguments from it by a method of substitution. The other version is used to translate English language into our symbolic form. The reasons for that we'll make clear later, but we're going to begin with where the book begins, and that is with the language we use to make arguments from by a substitution procedure. So here are the elements of our new symbolic language. Consists of lowercase letters of the alphabet called simple statement variables. That's what we'll be substituting actual statements for. More on that later. Every statement is either true or it's false. As far as logicians are concerned, that's the definition of a statement. We don't care what it's about, just that it's either true or false. Our language also consists of compound statements. So in no particular order, one of the compound statement forms is called negation. It's made with that symbol there called a curl. We call that a logical operator because it operates on whatever component follows it. The other symbols you'll find connect statements on either side. The curl does not. Whatever the curl's negating, as we said, is either true or false. But the negation of that statement, by definition, has the opposite truth value. So where the statement the curl is negating is true, then the curl is false. Where the statement it's negating is false, the curl is true. Now, that curl is the symbol that identifies this compound statement. That's the truth value of our compound statement form. Again, it's merely a function of whatever it happens to be negating. Questions about negation? We'll read that not P, or not Q, or not R, or not S. Whatever it happens to be negating. We have a compound statement form called conjunction. That symbol is called a dot. Those components on either side are called conjuncts, and we'll distinguish them as either the left or the right hand conjunct. We read that P and Q, P and Q. Now those two conjuncts are each either true or false. So what we're about to show is all possible truth value combinations for those two components. In other words, they may both be true, depending on what statements they are. P might be true and Q false. P might be false and Q true. Or they might both be false. And those are all possible combinations for the truth values of those two components. The truth value of that dot, or in other words, of the entire compound statement, the conjunction, it's a function of those truth values of the components. By definition, the dot is only true when both conjuncts are true. In every other case, our dot, or in other words, our conjunction, is false. Questions about conjunction? We have a compound statement form called disjunction. It's made with that symbol called a wedge. Those components are called disjuncts. So we'll distinguish them as being either the left or the right hand disjunct. We read that either P or Q. Those disjuncts, each one is either true or false. So again, I'm showing all possible combinations of their truth values. They may both be true, P true, Q false, P false, Q true. They may both be false. So the truth value of that wedge, which defines the compound statement as being a disjunction, it's a function of the truth values of those disjuncts. By definition, the wedge is only false when both disjuncts are false. In every other case, the wedge is true. Yes?
Can there be more? There can be more components, right? More than just two. And
absolutely.
If they would all still have to be true for the either conjunction.
No, we'll get to that shortly. The main symbol on either side, the main symbols have to be true. Yeah, that's a little bit complicated right now. We'll get to that shortly. Okay, questions about disjunction? We have a compound statement form called the conditional statement form. It's made with that symbol called a horseshoe. We read that if P, then Q. If P, then Q. Now those components have individual names. P is called the antecedent, and Q is called the consequent. In the case of the conditional statement, the relationship also has a separate name. It's called material implication. Now, P and Q, each one is either true or false. So again, I'm showing all possible truth-value combinations for those two components. By definition, the horseshoe, or in other words, a conditional statement. By definition, the horseshoe is only false when the antecedent is true and the consequent is false. In every other case, that's a true horseshoe, or in other words, a true conditional statement. Questions about material implication for the conditional statement form? Yes?
What was the name of the P value?
That component in a conditional statement form is called the antecedent. The antecedent.
Thank you.
Q is called the consequent. And the author introduces that and the last one later, but I like to get them out of the way right now. We have a compound statement form called the biconditional statement form. That symbol is called a tribar. And we read that P, if and only if, Q. P, if and only if, Q. Those components don't have special names. So we'll just refer to them as the left and the right hand components of our tribar. Just as with the horseshoe, the conditional statement form and the relationship that has a separate name, material implication, this relationship has its own name. So that's a tribar. The statement form is called a biconditional, but the relationship is called material equivalence. Material equivalence. Well, those components are each either true or false. So again, whatever they may be, in actuality, those are all possible truth-value combinations for those two components. Both true, P true, Q false, P false, Q true, both false. That's it. The truth value of that symbol, again, the tribar, or the biconditional statement form. It's a function of the truth values of the components. So by definition, the tribar is true when those components have the same truth value. So in our top row, they're both true. And in that case, we have a true tribar. In the bottom row, they're both false. So they have the same truth value. And our tribar is true there as well. In the other two cases, we have a false tribar, a false bicondition. Yes?
So the negation is the only one that isn't conditional based on the components.
No, it is, absolutely.
Just in a different way. Because it seemed to stand out the way that you
Only in the different way that it's a function of only what follows it.
Okay, rather than both.
Right.
Okay.
And again, for that reason, we call that a logical operator. It simply operates on what follows it. That symbol and the others, aside from the curl, those are called connectives, logical connectives, because obviously, in some sense, they connect components on either side. Questions about the biconditional? Well, as someone mentioned or asked, can the components that these compound statements contain, can they themselves be compound? Yeah, absolutely. They can be very compound. So in that case, we call it a complex compound statement. Now, that statement is meaningless because it's not defined as being a conjunction or a disjunction. We don't know what it is. So just as in math, we can distinguish what kind of equation it is with punctuation. We use the same punctuation that we do in arithmetic. So the first order that we resort to are parentheses. Parentheses around those numerals identify that equation as addition. It's an addition problem. If the punctuation were around those numerals, that would identify this as a multiplication problem. And as they have different solutions, it's obvious that that punctuation changes the meaning of those arithmetic statements. The same is true with our symbolic language. The punctuation were around those variables that would identify this statement form as a disjunction, whose left-hand disjunct is a conjunction. Were they around those variables, that would identify this statement form as conjunction, whose right-hand conjunct is a disjunction. Right? Okay, as these get more complex, we might have to resort to higher orders of punctuation. Now, we allow the curl to negate the smallest following symbol that punctuation permits. Well, that curl is negating P. That's the smallest symbol or component that punctuation permits the curl to operate on. So that's still a conjunction. It happens now to be a conjunction whose left-hand conjunct is negation, and whose right-hand conjunct is a disjunction. But were we to have the next order of punctuation, we resort to the brackets. That's a different statement. Now, this is a negation. And the symbol that punctuation permits that curl to operate on is whatever kind of statement is inside the brackets. Well, what we have inside the brackets is a conjunction. So that curl is negating the dot. The truth value of that curl then is a function of whatever truth value that dot has. The truth value of that dot is a function of whatever P is on the left and the wedge is on the right. And the truth value of that wedge is a function of Q and R. We have another order of punctuation. That's a meaningful statement. Let's squeeze this in a little bit. That's a meaningful statement. That is a conditional statement whose antecedent is are and whose consequent is a negation. Right? If I wanted to negate that horseshoe, I would have to, in this case, resort to our highest order of punctuation. The braces. So now that curl is permitted to operate on the smallest component that follows it, punctuation permitting. Well, that means it's operating on whatever kind of statement is contained within the braces. And that happens to be the horseshoe. That's negation of a conditional statement. Can we read it that way? Questions?
Is that a relatively complicated example? Or will that be the kind of thing that we're seeing in the text?
Oh, they get more complicated than that.
Well, all right. Well, yeah. Is there English language equivalents that will be translating to
Yep.
that form?
Perhaps.
More or less.
Certainly that many symbols, and some complex enough to have braces. Yeah, sure. You'll pick it up. Okay, review. Simple statement variable, lowercase letters of the alphabet, because the person who invented it decided that way. That's it. We'll substitute actual statements for those variables and eventually compose entire arguments from them. But this is our base language. It's what we start with when we want to make a valid argument. Every statement is either true or false. That's a compound statement form. That means that it's a statement that contains at least one other as a component. So the statement curl P contains P as a component of the negation. P again is either true or false. The truth value of the negation, the compound statement itself, is a function of P. By definition, the curl has the opposite truth value of whatever it negates. That's a conjunction. Components are called conjuncts, left and right. That symbol is called a dot. We read it P and Q. Those are all possible truth value combinations for those components, P and Q. The truth value of the dot, or in other words, of the conjunction, is a function of the truth values of P and Q. Now, what is that function? By definition, the dot is only true when both conjuncts are true. Otherwise, we have a false dot, or in other words, a false conjunction. The disjunction. Components are called disjuncts. That symbol is called a wedge. Read that either P or Q. Those are all possible truth value combinations for P and Q. The truth value of the wedge is a function of those truth values. What is that function? By definition, the wedge is only false when both disjuncts are false. Otherwise, our wedge is true. Compound statement form called the conditional statement form. The relationship is called material implication. It's made with that symbol called a horseshoe. Those components, P and Q, are called the antecedent and consequent, respectively. We read that if P, then Q. P and Q are each either true or false. Those are all possible truth values for those two components. The truth value of the horseshoe, or in other words, of the conditional statement form. It's a function of the truth values of P and Q, the antecedent and the consequent. By definition, the horseshoe is only false when the antecedent is true and the consequent is false. In every other case, we have a true horseshoe.
Was that a disjunction as well?
What?
The horseshoe one?
No, disjunction is the name of this statement form made with a with.
Oh,
This is called a conditional statement form.
okay, thank you.
Conditional. That's called a biconditional statement form. The relationship is called material equivalence. Those components, P and Q, don't have any special names. We read that P if and only if Q. Symbol is a tribar, if I forgot to mention that. P and Q are each either true or false. No getting around that. Those are all possible truth value combinations for those two components. The truth value of the tribar, or in other words, the biconditional statement form, is a function of those truth values. What is that function? By definition, the tribar is true if both components have the same truth value. Either both true or both false. So on our top row we have a true tribar, bottom row we have a true tribar. Those components have different truth values, we have a false biconditional. And I'm not going to go through our punctuation again right now on the board because I'm going to turn to the book and look at some exercises. It'll have us identify all these things we just talked about and then begin to be able to read our compound statement forms. See, when they get more complex, reading them is a little bit more challenging. But you're going to have to know how to read them. Because when we translate English into our symbolic language, the English doesn't contain the parentheses and brackets or braces. We're going to have to figure out where they go. And the only way to figure out if you punctuated your symbolic statement correctly is if you're able to read it back against the English. And 9 times out of 10, key words will be spoken at the same point in both your translation and the English language. So if you don't have any questions, I'm going to look at an exercise in the book. We'll practice what we just talked about. Yes?
Is there, what is this used for? Is this used for any sort of life application?
Absolutely.
Okay,
Would you like to know what they are?
yeah.
Yeah. Doctors, lawyers, engineers, computer programmers. Yeah, all use symbolic language.
Okay.
Mathematicians.
Mr. Gray?
Yes.
It's only negated when you have the whole sentence is only negated when you have
Curly on the outside.
then it's only negated, then the whole sentence is only negated then?
Not exactly sure
Is there parentheses on the whole thing?
what you're referring to, but I think we'll answer your question when we look at these examples.
Okay.
See that okay?
What page was that?
This is on page 299. Well, the first thing you'll notice is that these statements have uppercase letters. So we're to assume that these represent English statements that have been translated into our symbolic language. You don't have to worry about how to do that right now. It's just, that's what we use the uppercase letters for, and there are a couple of reasons for it that we'll get around to later. So you'll notice that these get progressively more complex. Start out pretty short, pretty easy, and by the time you get down to number 25, that's a pretty complex compound statement right there. And a lot of these are so repetitive, so similar, that we can skip them. For example, 1, 3, 2, and 4, the only thing different about them is the uppercase letters. Okay, let me ask you a number of things about these examples. For example, what kind of compound statement do we have in number 1? What kind of a compound statement is that?
Disjunction.
It's a disjunction. And what do we call that symbol that makes a disjunction? It's a wedge. What do we call those components of a disjunction?
Disjunct.
Disjuncts. What kind of a compound statement do we have in the left-hand disjunct? It's a negation. What do we call that symbol? A curl. Okay, now the symbol that defines a compound statement as being one of these, a negation, a conjunction, a disjunction, a horseshoe, a tribar, we call it the main connective if it's something other than a curl. In that case, we call it the main operator. Well, this compound statement is a disjunction. So we would say the main connective is that wedge. That's the symbol that defines this as the kind of compound statement that it is. Now, when we read a disjunction, we begin with the word either. And then we go to the left-hand disjunct and read whatever that is. Back to the wedge and say the word or. Then to the right-hand side and read whatever kind of a component that is. So, if it's just the disjunctive statement form, we simply say either P or Q. But you'll find when we go to the left-hand disjunct, after saying the word either, we've got a compound statement there. It's a negation. So you have to read it the way we read a negation, then back to the wedge, or, the word or, and then back to the right-hand side. Now, there are no exercises in the book that specifically have you learn how to read these. So when we have spare time, but especially at the beginning of this section, we are going to spend some time. And I bet in 10 minutes, most of you, in 10 minutes, some of you, are going to be able to read anything on this page or in this book. Because it's a matter of saying the words at the appropriate time. And if you know how to read the basic statement forms, you should be able to compound the order of words that must be spoken. Number 1, we would read either not A or B. Now, since we're skipping 2, 3, and 4, it's going to start getting a little bit more complex immediately. What is our main connective of this statement, number 5 right here? What is the main connective?
The wedge.
It's a wedge. What does that mean? It means that this is a disjunction we're looking at, right? What kind of a compound statement is my left-hand disjunct?
Conjunction.
It is a conjunction. Now, what kind of a compound statement is my right-hand disjunct?
A conjunction.
It's a conjunction. Okay, note, I didn't mention this before because it didn't come up. When we read a conjunction, simply read that, for example, P and Q. When we have a conjunction in punctuation, we have to introduce that conjunction with the word both. So that would be read not both P and Q. And the reason is that will distinguish those two statements. The one on the bottom is simply read not P and Q. But it's a very different, has different meaning from the one above it. And the way we distinguish the two, again, we introduce a conjunction within punctuation with the word both. So that one on the top, that is not both P and Q. The one on the bottom is simply not P and Q. Well, in number 5, we have dots within punctuation. So keep in mind when we read it, we have to introduce each dot, each conjunction, with the word both. I'll do this one. Either both A and X or both B and Y. Agreed? Okay, now if you look at number 7, there's one difference. There's a curl negating that first conjunction. This is still a disjunction. That wedge is still the main connective. The left-hand disjunct happens to be a negation, and it's negating a conjunction. The right-hand disjunct is simply a conjunction. I wonder if anybody could take a stab at reading. Is that a question or a volunteer? All right. Here, I'll follow the bouncing point of the pencil, and I'll point to symbols where something has to be said.
Either not both C and Y, or both A and Z.
Right on. Yep, very nice. You'll notice that 9 is the same, 8 happens to be the same, whether you can see it or not. Look at number 10 over here. Well, it's a little bit more complex. Again, the main connective is a wedge. We're looking at a disjunction here. The left-hand disjunct is a negation. That curl is negating a conjunction. Note that the right-hand conjunct is a curl. On the right-hand side of the wedge, we have a conjunction. Left-hand conjunct is simply B. Right-hand conjunct is a curl. Would anybody like to take a stab? And we'll notice that both of our dots, again, are within punctuation. So, would anybody like to have a go at reading this? I bet some of you can already. It's sort of intuitive. If you know how to read the basic statement forms, it's just a matter of, remembering to say the right words when you come to different symbols. You're going to take a go at this?
I'll try.
Okay, follow the bouncing pencil point. What are we on, number 10?
Yeah.
Okay.
So either not X.
No.
Oh, both X and
Okay,
Y.
you got to start again.
All right. Either not.
Oh.
Sorry. Either not both X and not Y, or both B and not C.
That's a go. Let's see what else we have here. Right below that, might as well stay there. Right below that we have what's the main connective?
Conjunction.
It's the dot. The main connective is the dot. So that means it identifies this compound statement as a conjunction. We note that both the conjuncts are disjunction. But that dot is not within punctuation, right? And although the wedges are, you don't read them any differently. See, the word both, it's the only time you have to add something, and that's when a dot is in punctuation. So you're going to read a conjunction, and you're going to read both sides as disjunctions. I bet somebody could do that right now. How do you begin to read a conjunction? You simply read the left-hand side, right? The left-hand side is a disjunction, so you're going to read that. You'll come back to the dot. That's where we say and then you read the right-hand side. Are you good to go? Okay.
Would you use or would you use either? Would you
Either
just,
or.
A disjunction is read either P or Q.
Okay. So either B or C, and either Y or Z.
See how easy that is? Let's stay right there and look at number 14. Very similar. Don't have to go through all the questions except to note that the left-hand conjunct is a negation now. It's negating a disjunction. Somebody new?